The Ministry of Sovereign Intelligence, Agent 26, Sterling Vane. Real science, real stakes.
Vane. The sonar is reading microfractures in the ceiling at, oh god, 47 separate points. The whole karst shelf is singing.
I know. I can hear it.
Structural projection puts primary collapse in under 4 minutes, Sterling. The cavitation shockwaves have already propagated into the fault lines. She fires that lance again, and you are inside a limestone coffin.
Vane, I have an absolutely extraordinary idea.
You do not.
I've got a shaped microcharge on the dive rig. I could...
Cooper.
Right. No explosions. In the cave, where Vane is. I heard myself.
I know you're in here, Agent. I can hear you breathe. The bay carries sound beautifully. 3 minutes, and I'm gone with the hardware. You are welcome to the ceiling.
4 minutes, actually. And I don't need 4.
What is he doing? Conduit, what is he doing?
Physics. Mr. Thorne. It's taking the edge off.
The lance is firing. Why isn't the ceiling moving?
Because the bubbles have somewhere softer to go. 15 hours earlier, London.
It says, unrecognized biometric. That's my hand. I've had this hand my whole life.
You updated your smart ring firmware at 6 a.m. The biometric handshake protocol doesn't recognize the new encryption signature.
That is an extraordinary flaw in a security system.
It's an extraordinary flaw in you, Cooper. You updated a classified biometric device on a ministry-secured network during an active threat assessment window.
I just wanted the sleep tracking feature.
The sleep tracking feature.
It charts REM cycles.
Stand on the secondary plate.
Vane, you smell like a reef.
Coral. The Maldives brief ran long. Dried tuna. They press it in palm leaves. You'll find it remarkable.
I'll find it structurally compromised.
How bad is it?
48 hours, possibly less. We'll use the briefing room. Case file, Dragon's Breath. Subject, Nadia Solberg, Norwegian national, former deep-sea salvage contractor for 3 North Sea energy firms. Current occupation, black market antiquities. Method of procurement, theft from underwater archaeological and classified sites. Method of entry, this.
Is that a weapon?
It's a cavitation lance.
Wait, what?
It creates rapid, localized pressure drops in water. The liquid vaporizes in that instant microscopic bubbles form. Then the surrounding pressure collapses them violently inward. The implosion releases a focused shockwave strong enough to pit hardened steel, silently. No drill, no explosive. The mantis shrimp evolved the same mechanism. It strikes with its club so fast that the water beside it vaporizes. The prey is hit twice once by the claw, and again a fraction of a second later when the bubble collapses behind it.
The shrimp does this?
With rather more elegance than Solberg, yes.
Solberg used the lance 3 days ago on a sealed Cold War submarine vault inside a tidal sea cave in Ha Long Bay, Vietnam. The vault was Soviet-era, classified. Its contents, navigation hardware from a decommissioned guidance program, sufficiently functional to retro-engineer for current applications. The kind of applications that generate bidding wars in very dark rooms.
Who's buying?
3 parties with mutually incompatible geopolitical interests, which is precisely why the Dean wants it recovered before it's sold to any of them.
Agent 26. The vault is cracked, but not yet fully breached. Solberg returns tonight for the final extraction. The problem is, the cavitation shockwaves have destabilized the surrounding karst limestone. Our structural analysis suggests the cave is already compromised. One more hard firing of that lance, and the ceiling comes down, with Solberg and the hardware inside it.
She'll know that.
She does. She's calculated a narrow firing window enough to breach the final panel, extract, and exit before the collapse. The margin is 7 minutes, possibly 4. Our geologists disagree.
So, we wait until she's inside and then...
Then nothing, Cooper. The hardware goes down with the ceiling, and we've solved nothing except Solberg's pension plan.
You need to be inside that cave before she arrives. Vane, the lance, must be neutralized. The vault hardware must be recovered intact, and that ceiling must remain standing. All three, sequentially, and without making a single loud noise.
What's the dissolved gas content of the water in that grotto?
It's low, almost certainly. It's a sealed tidal cave, limited surface exchange. I've taken the liberty of adding 2 canisters of supersaturated CO2 solution to your dive kit. Enough to saturate the grotto volume several times over.
You already knew.
I knew the moment you looked at the topology and not the lance. Don't be smug about it.
I feel like I've missed something.
You'll feel it more clearly in Ha Long Bay.
I've preloaded a lateral scan sonar array that maps cave fractures in real time, a pressure depth AI that auto-calculates collapse windows, a dive beacon that triangulates to within 30 centimeters, and a microspectrometer for identifying the vaults.
Does it need charging?
It needs 40 minutes.
For 3 hours of power remaining. No charger required. 14 hours later. Ha Long Bay. Southern approach.
Sonar is okay. It's at 60% charge. That's fine. Sonar is showing the grotto approximately 90 meters through the submerged karst tunnel. Linear passage. 2 tight squeezes. The vault chamber opens into a larger air pocket. You'll have overhead clearance once you're through.
And in Solberg.
Surface radar shows her dive tender, rounding the eastern karst in approximately 19 minutes.
Good. Conduit. Estimated dissolved gas concentration in the grotto water ahead.
Based on cave depth, tidal exchange rate, and water temperature, estimated 1.2 milligrams per liter dissolved CO2, near zero free gas content. The water is effectively degassed.
And the effect of discharging both canisters into that volume?
Dissolved CO2 concentration would reach approximately 700 milligrams per liter near saturation at ambient pressure. Cavitation bubbles forming under lance pressure would draw in dissolved CO2 and fill with compressible gas rather than pure vapor. Collapse dynamics would shift from inertial to non-inertial. Shockwave peak pressure, negligible.
She's 12 minutes out. Vane, the structural readings are worse than the briefing said. That ceiling has already fractured in 3 sectors.
Cooper, let him work.
7 minutes. Her sonar will have painted the tunnel by now. She knows you're in there.
Good. She'll also know the ceiling is unstable. She'll move fast.
The lance just armed itself. Did she arm it remotely? Vane. She armed the lance.
Vane.
She's welcome to it.
It's firing, but there's no strike.
The bubbles are forming, Miss Solberg. They simply have nothing to collapse into. The water is saturated with dissolved CO2. When the lance fires, the vapor bubbles draw in that gas. They fill with something compressible, and a bubble full of gas doesn't implode, it just deflates. The shockwave never arrives.
You poisoned the water.
I cushioned it. There's a difference. The ceiling will stand. It was the hard collapses destabilizing it. Soft collapses, gas dampened, release almost no energy into the surrounding rock. Remove the shockwave, the fractures stop propagating. The hardware is intact.
What just happened?
He took the bang out of the bubbles. Stop cluttering the channel.
So, the dissolved gas damping principle, I've been thinking about it, and I've actually fitted a CO2 injection module to my new dive watch.
Does it need charging?
It needs 20 minutes.
The Dean wants a debrief in 10. And he has another file, Slovakia.
What's in Slovakia?
A supercooled particle collider, a missing isotope, and someone who thinks they understand thermodynamics.
They never do.
Agent 26. Slovakia is getting impatient.
Slovakia can wait 40 minutes. I need to wind my watch. Cavitation. When a liquid is subjected to rapid, localized pressure changes the kind generated by an underwater lance. The pressure in that tiny region drops below the water's vapor point. The liquid doesn't boil from heat, it boils from the absence of pressure. Microscopic bubbles of vapor form in a fraction of a millisecond. And then the surrounding pressure reasserts itself, and those bubbles implode violently, asymmetrically, releasing focused shockwaves powerful enough to pit hardened steel. The mantis shrimp has perfected this principle. It swings a club-like appendage at speeds that vaporize the water beside it. Its prey is struck twice, once by the physical blow, and a fraction of a second later by the shockwave from the collapsing bubble. The claw lands first, then the physics arrives behind it. The key to the shockwave is what is inside the bubble at the moment of collapse. A vapor bubble, pure vacuum, essentially implodes with full, catastrophic force. Nothing to resist the inward rush of water. But a bubble that is drawn in dissolved gas is a different thing entirely. Gas is compressible. As the water collapses inward, the gas inside absorbs the pressure, cushions the walls, and bounces back gently. The collapse becomes non-inertial. The shockwave peak falls to almost nothing. Supersaturate the surrounding water with dissolved CO2, and every bubble the lance generates will fill with that gas before it can close. The weapon fires. The bubbles form. They simply cannot destroy anything. The lance cycles in silence, not because physics failed, but because physics, as always, found a softer solution first. The ceiling stood. The hardware was recovered. And somewhere in Halong Bay, a cavitation lance sits on the floor of an evidence locker, full of mechanisms that work perfectly and accomplish absolutely nothing.